This is actually our third video on our aquaponics system. As you can see, everything is going very well. This is a 6-week lettuce. It's actually doing very well like the water system. I will explain later how the process works. But so far, from just this test system, so far we've had a really good result. So I think we're gonna probably keep the same design. I am doing this as my thesis on aquaponics, my senior thesis for school. But again, I also want to do this as a small scale agriculture and actually expand it to third world countries. It's just a good way to actually for sustainable agriculture, and I think they need it more than us. So I'm just gonna go and break down on a few plants and see how each and every single plants we actually grew here, how they're actually doing. Here we have a tomato plant that's doing very good. You can see it loves this system. Very healthy looking tomatoes. Right now we're actually working on kind of a way to find a stability for it. We'll actually put some holes over here and a string up here to hold it and make it stable. And I'm going to explain how the whole science behind it works in a little bit. Here we have herbs. This is basil. Everybody likes that, and it's actually doing very well. And over here we have collards, very healthy. 5 weeks in, it's growing very, very good, and you can see a good, healthy, clean root system over here. I actually took it to the extreme, and we wanted to see even the bigger plants, will this system be able to support the root system? And we decided to actually grow bell pepper. This is bell pepper, and it's actually doing very good, and it's very healthy. You can see the root system's following the nutrients in the water. And we have to space out the plants. These lettuce over here, they're actually 2 weeks behind compared to the big lettuce, and that way when we harvest we have something else ready. And now we're gonna go to the science behind it. So under here we have our little fishes. These are actually goldfish. I have 20 goldfish here. You will see them as I feed them. They'll come out here and start eating. These are the guys that makes everything happen right now. You know, it's a recommend to have edible fishes, and that way you have both your vegetables and protein from edible species. But I am not going to do that. We're not going to do that until next year when I start some tilapias. So this is how the system works. This is our grow medium. Over here we have cucumbers. We just threw these seeds in and everything else grew. This is where the bacteria converts ammonia to nitrite and then nitrates. It eventually takes almost 12 weeks for the conversion to complete, even though some people claim otherwise. They say it takes sooner, but with the science and the whole conversion, I think it takes 12 weeks with my observation myself. What happens, the water from the fish tanks get pumped up to the system. When it comes down here, the water goes on the media itself, and here, as you can see in the center of it, we have what is called a bell siphon. A bell siphon acts as a dry and flow system. What happens is drain and flood system. It drains the bed and let it flood. When I say flood, it's not necessarily the roots that are getting flooded, but it's the bed itself, these planter box. So when it goes up, it kicks in the bell siphon. Right now the bell siphon is closed, so nothing is happening. The bed is flooding, and then as soon as it gets on the very top, on the level where we want it to, then it's gonna kick in and it's gonna drain the whole bed. That way we're avoiding the roots from getting flooded with constant flow of water, and the water to be stagnant in the bed itself, and also prevents the algae enables the bacteria to have enough time to get the oxygen um, when it's flooded, so the oxygen actually seeps in there, and also the nitrogen from the air too gets a little bit. You can see now it's flooding, and then it's gonna drain it all. So it's flooding to their point, and then it's gonna kick in and drain it all. You'll see. 1, 2, 3, yes. So now it's draining the whole system. This is just a mechanical system. We don't use electricity on this part. Everything is just physics, simple physics. It's just air, maintaining the air pressures from outside of the pipe and inside the pipe. And then when that equalizes, it sucks water in, and the water pushes down the water. The air pushes down the water. Uh, when the bubbles get to the water itself, it enables the fish to get oxygen. As you can see, they love these water bubbles. For a 50-gallon tank, what we are using there now for testing, it's enough to make sure fishes are getting optimal temperature and optimal oxygen for their survival. And of course, with this system, since we are solely depending on fish to be the source of ammonia, we need them to be happy. So once they are happy, our plants are gonna be happy. As you can see, this is the results of happy fishes. So it is the conversion. To go into more details, it is all about the conversion of ammonia to nitrite and then nitrates. The nitrosomonas bacteria converts ammonia to nitrite from NH4 to NO minus 2. It's a nitrosomonas, and then from NO minus 3, it's a nitrobacter bacteria. They convert the nitrite to nitrates, and that eventually takes the whole cycle complete in 3 to 12 weeks. To my experience, that's when I actually was able to test the water and see actually there is a substantial amount of nitrates to support the plants. But some people, depending on the amount of ammonia, depending on how fast the media is and how the bacteria are working, it could be different. It's just, that is just from my experience so far. And I hope maybe in the future it will form even sooner. We did have a little problem with the system, which we're going to have to tweak it a little bit on the water levels. Some plants don't want a constant flow of the water level, but this is also not an NFT system. It's an NFT system crossed with the WC system, deep water culture. What happens is we don't have just a column of water at the bottom, but we have a halfway filled. In that way, you get just enough room on the oxygen to flow in the tank, in the pipes itself, on the 4-inch pipes, the PVC, and also the bubbles to flow and enable oxygen and the roots not to be um, flooded. Okay, and on the system itself, it covers a footprint of 4 by 6. Okay, that could be the same amount as what a regular farmer will have a planter bed itself. But this is small. The footprint of this is very small. It's twice the yield of what you can grow on a regular plant. You don't have to water. You don't have to worry about weeds. You don't have to use expensive fertilizers. And your plants are 100% organic. So you're eating healthy. Healthy body, healthy mind. So that's our target, and that's the future. Every single thing from this system grew from the seed. Put a seed in the plant on the media, and everything just grew just like that. The lettuce actually sprouted in 3 days, literally 3 days. But after the conversion of the nitrates was complete. To go into more details, we've had a problem, as you can see on the leaf over here. The plants were getting burned a little bit because it was 110 degrees here in the summer, and we didn't have any curb, any barrier to do it to protect the plants from that. And as you can see, we're still outdoor, just like any outdoor plants will be, and they're still doing very well. So we're actually building a greenhouse right now, which is 8 by 32, approximately 246 square feet. It's gonna have a design, almost similar design to this, the system that you have seen, but we are trying to actually make this more so efficient in a way we can actually maximize we're trying to have 10 times of what we can grow in there. Probably be a local supply of lettuce in this tree, so hopefully that will actually work out. And that'll be it. You'll actually get an update on how we're doing, and once we start raising our eatable fish, specific tilapia or bluegill, we haven't decided yet, but once we get to that point, you guys will get more feedback. Thank you. So far, I am going to actually show you one of the lettuce. This guy is actually 4 weeks. So it's 4 weeks, it's getting to fully grown because the lettuce usually go up to 6 weeks. But it looks very healthy, as you can see. Good green, good part. Like you can see how the leaves are broad and how green they look. And you can see the roots. Look how clean these guys are. So it shows you exactly there is actually good filtration system from the water itself. It's only a 4-inch PVC pipe, and I'll go into details on how the system itself works and how it is, okay? So this is just what we have. It's just a regular lettuce, like I said before. And over here, we got this big guy over here. This guy is just regular coral. Can you get this one real quick? Look how big and healthy this guy looks, okay? So it's getting ready for harvesting. We're probably going to have some colors today. Everything organic, no fertilizer whatsoever. The healthy eats right. That's what we are talking about. That's what everybody's talking about, right? And over here, I'm going to show you just a little tomato, right? It's a yellow Roma tomato. These are very unique, actually. I love this thing because it's going to have actually, when they ripe, they actually turn yellow. So it looks good, and it's healthy. It's a little short. I don't know what's happening over here, but I feel like it's getting enough nutrients. It shows that it's healthy, but it's already flowering. So I guess this is the height they go up to, but again, it's all testing. I guess we're gonna have a lot to find out. So this is just one of the yellow Roma tomato, like I told you. Eat a lot of collards, eat a lot of broccoli. I'm gonna grow a lot of broccoli on this system because so far it's showing that it's actually able to support even the bigger root system. Over here on the very top, you can see I got this another collar. Looks very healthy, and I decided to actually put holes on the side of the PVC. In that way I can fit more plants on one pipe. So I have this hole on this side. It's targeted to the other hole. The other hole is in the middle. It's targeted on the other side. But this came out and just followed light, so it just worked like I thought it will, you know. So as the letters is coming out and go up, okay. We have a lot of different plants. I actually went from lettuce to bell pepper. I have a little bell pepper, one of my favorite. You know, I'm still waiting for this guy. It's taking its sweet time to grow, but I'm like, hurry up. I want to see if you're actually going to get fruits. We have the other bell pepper on the other side that's growing fruits, but I have special interest on this because this is yellow, so we will see how this turns out to be, okay? Over here, I have my very first lettuce. This guy was like one of the first 7 weeks, okay? And I kind of let it overgrow, you know, and just look at it because I love it. It looks good. It should have been harvested a long time ago. I wanted to see, you know, how much root system this system will be able to support. So far I only know lettuce doesn't really have that much roots, but the system can handle quite a bit of amount of lettuce in it, and it will actually be more perfect. It will be perfect for lettuce because lettuce seems to do better than anything else, and that is my interest anyways, okay? If you can come on this side, I will show you even bigger plants with much larger root systems like tomatoes. We have this tomato over here. It's actually those big, kind of rounded, and it has like lines on it everywhere. There's a lot of fruits in it. You can see, like, this is actually 7 weeks. I put this seed same way, same day as I put that first lettuce that I showed over there, and you can see the fruits like everywhere. So we're gonna have to come up with a way that I can actually put like a string down here and go up there on the stand itself to support it, even though so far it's doing very well because it's just leaning over the pipe, and it's probably gonna lean on this other pipe and go up, okay? We have basil. herbs. Everybody loves these guys. You gotta have basil. It's not doing very well as I thought it would, but it's still growing from seed. So that is what I wanted to test. It means if we can get to this point, I can just move it to the plant, to the grow media, and it will still do very well. The only problem that this guy is getting right now, it doesn't like a lot of sun. And over here in California, we are facing like 100 degrees of temperature. Because of that, the guy looked a little yellow, not because of the nutrients, lack of nutrients, because it's just right next to the tomato, and the tomato is almost like a pH scale plant that you can see all your pH level, the nitrate level, by looking at the tomato itself. So that's why you have to have at least one tomato in your system to actually look for the pH levels. That's just another. Look at this guy. It's a small color, so it's gonna give you an estimate of a root system what a bigger color like this will have. Okay, this guy is still growing. Okay, it's a rotation system. That's why you have bigger plants, you have smaller plants. Once you harvest this one, you want this one to be growing, so you have constant supply of plants throughout the year. Okay, and you know, right now we're still working on the process. We need to have a greenhouse, and now where we can have a more controlled environment, like I said earlier. But that is work in progress, of course. You're not going to have everything in one day, right? Okay, so this is it. Look at that. Looks like a beard a little bit, almost like this beard. Okay, that is another collard right there. Show you bell pepper already. Show you basil already. Show you regular peppers over on that side. They're doing very well. I'm gonna have a bigger system like this on our greenhouse that we're building right now, me and my friend Bob. We're gonna have that with, it's a 8 by 44, close to 44, so close to 250 around that area square feet. It's not very big, but we want to see how much we can produce in that footprint, because right now we're on 4 by 6 footprint and we're producing just enough to have 3 planter beds without any use of fertilizer, without have to water it any single time of the day. I do this, I go to school, I go to work, come back home, get fresh vegetables. Anybody can do it, whether you're in town or whether you don't have water. The only thing you need to start is 50 gallons of water. So if you can fetch this at the river and let it for the chlorine to go away and have your fish, you can have fish and vegetables in a 50-gallon tank. So you can do it. Okay? The reason I'm doing this, I have a special interest, especially being from the tropical countries where it's very hot. We have a very good supply of water. But again, the access for water is very limited. People don't get access of water like how we do here. Okay? So those people can have a tank and fish tank and just fetch water in the river, like how you do it in the water tap. Whatever you can get it, let the chlorine go away, put your fish in there. At the end of the day, you're going to have protein, very good protein, source of protein. Right now I'm using goldfish, I can't eat them, but starting with tilapia or bluegill, you can eat them. And a greenhouse provides the controlled environment, so that's why I'm so excited about this, and I am very happy for it. I will show you, I'll have a video follow-up after I'm done with my thesis in the greenhouse. It's going to be done at the end of the semester when I graduate. But I will show you, I'll make a follow-up video to show you how the greenhouse looks. Thank you very much.